Right. See you later. Okay. So I'm working on updating your grades. I'm sorry. Um, I'll get it done by Friday or Saturday. Everything on the class.
Do I hand you this right now?
You can just put it back. Thank you. Okay, so this week we are gonna talk a little bit more about forensic and the computer component. I think this is review for many of you, and this might help for those of you who want to understand more of the hardware, what we're looking for when we're doing computer forensic. So it's kind of, important to make sure that we're on the same page. Later on, you are going to be doing file carving. And also today you see some of that. So we want to understand how the drive works, how RAM works, things like that. So the computer components is crucial. So you need to have at least a basic understanding of the hardware, and that's what it talks about here. If you haven't taken like CIS25 or another class that's similar to that, this kind of give you the overview on how to work with the computer system. So here it talks about how the investigator is going to gather the digital evidence and working with the process. And a lot of the time, we're going to work with storage devices like solid state drive or hard drive or external hard drive. We don't want to make a mistake and not be able to have the proper image and the storage that we need. If we don't understand the proper functionality of the components, we might run into problems in finding our digital evidence, and that can be critical for testifying in the court of law. So in the investigation, we need to have a thorough understanding where the data is stored or accessed or modified. We want to be able to understand how to utilize the devices in our system and understand how the operating system works and where the files go. So in the first question, it asks you, why does the digital forensic investigator need to know the different operating system, file system, and boot processes? So when you turn on your computer is going to go through the boot process, and it's going to load the operating system, which is mostly used to interface with the user so that way the user can store files, access applications and resources. So the operating system as a whole is a way for the human to interface with the hardware. It is a software for us to be able to access our files, store data, and retrieve the data or access application that we can use, such as our browser, to connect to the internet. And in the boot process, we need to understand what's happening, because sometimes we need to really gather the evidence in these processes. So the answer for number one here states that the technical knowledge of the operating system and the file systems and the boot process will minimize investigation mistakes. And sometimes it could alter or modify your evidence, which can impact investigation integrity and the credibility of the investigator. So it's really important for us to have the technical knowledge and skills to work with the operating system. Understand that the Microsoft operating system is different than the Mac operating system or the Apple operating system, like iOS and Mac OS or Linux, because each operating system type will store files differently, which is known as the file system. And during the boot process, it would probably, most operating system would check devices to make sure that the hardware devices are recognized, but there are different type of files that are being used in the boot process to be able to bring up, right, the software packages, to accumulate the software packages to be able to display the interface and all the components for that operating system. So to really avoid mistakes, and modifying what we see as evidence that could impact the integrity of our investigation and our credibility, we want to make sure we have the technical knowledge and skills. Now, in computer forensic, we don't have to be super well versed in this area, right? Having basic understanding of how the components in the system works will be good. And you don't have to have formal training or certifications in like CompTIA A+. It's good that you have it, but I think having the understanding, the knowledge in it is adequate. So you can also self-learn, you can also be able to read books, access tutorials online, and be able to go through the process or take a course, right? That will be a formal training. Any question? Okay. So that covers the first section of our notes. On page 1, on the next section, it talks about power on self-test posts. And traditionally, this is done and you would hear a beep from the computer when you turn it on, especially for the PC, right? The personal computer that runs Microsoft Windows operating system. So what that does is it really checks. So the motherboard is like the nervous system of the computer. It interconnects all the devices, including the drive, right? The memory, and also the components for communication, like network adapter, video adapter, etc. Some of it is on board and some of it is attached to a bus, which is a connection point on the motherboard. And with that, when it does the power on self-test, the processor access the ROM, which is stored, and that's read-only memory, right? It references that for information. And it does the basic input-output system, so your BIOS is accessed to be able to determine what devices are connected onto the motherboard. So if you have a new drive, right, and that drive is configured, it's going to detect that drive as a solid-state drive or, you know, a hard drive, etc. Or if you have a video adapter, it uses this information to be able to check to make sure that those devices are connected. So ultimately, the processor, it's like going through and taking roll, right? Taking roll of all the devices that connected inside the computer. It's like the processor is like the teacher and all the components are like the students. So it's making sure that all of the students are there, all of the devices are connected, talking, receiving signal. So it does the power on self-test. Because when we generate power, that signal goes through and it's able to verify that those devices are well and they're connected. So when you hear a short beep or if you hear a different set of beeps, it's really an indicator to whether the computer needs your attention or the computer is doing well, right? So the power on self-test, when that goes through, if your RAM is disconnected, it's gonna give you a chain of beep continuously. That it's telling you that the computer is incomplete, right? It needs some attention, but you hear a short beep or you might not even hear a beep, everything is good, and then it loads the operating system. So in the boot process, this is the first step that it takes. And then it's gonna, if it is not able to access the media, then it's gonna be able to not be able to access the operating system, because ultimately the operating system is stored on the drive, right? The solid state drive or the hard drive. So now when you boot the computer, let's say that you confiscated the computer for the investigation and that computer is shut down. You have to understand that when you start that system, it updates some of the information in the boot process, right? It's checking for the devices, but then it's also going to change a little bit of the state of the system that, you know, some application might be running in the background once the operating system starts, and so on. So keep in mind that, you know, when we turning things off and on, that can impact the result of our investigation. So we want to make sure that we document it, right? And how it was found. So in order to take an image of it, of course, you have to turn it on. But when you're turning it on, right, it could access certain files or certain application. So here it talks about that. And then in the more modern system, that this is what you see now, it uses the Unified Extensible Firmware Interface, which is UEFI instead of the complete BIOS function. So some of you can access this to be able to go through and modify your hardware configuration or troubleshoot. Sometimes we would see that, right? And it is part of the operating system, you know, recovery process. Okay. So this is going to give us a quicker startup. So let's come back to here. So what occurs in the power on self-test, your post, it basically tests the essential motherboard functions. And remember that the motherboard is the nervous system for the computer. It like your nervous system, right? It's connecting to your heart, your brain, right? Even your stomach, your feet, your leg, your veins. So it's able to interconnect the devices within the computer. So when we do the power on self-test, it's going to test the essential motherboard functions to see if the device is receiving signal from the processor through the motherboard. And it verifies the components in the devices are connected and can be used. So what they are, if they're connected, right? So it's able to verify that. And if the device is not connected, right, it would either sound off an error code or it would notify you as a user that it cannot start the operating system without storage or RAM. If your display is not fully configured, it'd still be able to start your operating system, but it won't show as, you know, the image as clear or with the high resolution that's what you need. So there are truly crucial devices like your storage components. And then in some cases, if you're trying to access the internet, even if your network adapter is not fully configured, right, it'd still be able to boot the operating system. It just won't let you connect to the internet. Now, how can you go about changing the boot setting in your Windows system, right? Why is this step necessary for investigation? So in the traditional system, in the older system, we would be able to access basic input-output system, which is your BIOS menu. And in order to do that, we can simply press a function key. It depends on the motherboard manufacturer, or you can look up that model number and be able to see. So if I'm working with a Dell laptop, right, I can check to see if whether I'm using F10 or F12. So you can always go to the manufacturer website to verify that. So when you press the function key and you have to tap it continuously, you'll be able to access BIOS menu. And this allows you to modify what storage device it's going to use to boot. So your boot priority settings. I might want to boot from my one of my 3 drives, right? So I can specify which drive. I can also tell it to boot from USB if I want, or in the older system, we can have it to the optical drive or CD or DVD. So we can modify the boot priority on which storage uh device that's gonna be able to have the boot files that it needs for the OS. Now we want to change the boot option so that way we can have the proper drive access, and that drive would contain our artifacts for evidence acquisition, right? But we don't want to modify the complete system of the suspect. We want to take an image of that drive, but we don't want to modify that system completely. So that means that we need to change the boot option to access the drive only, right? We don't want to be able to modify the complete state of the system, just to access that drive and take an image of it. And remember that you always examine the image, but not the actual system, okay? Because you can modify their files if you access it directly. So I don't turn it on and be able to open up files and look for the files. I take a capture of the image of that computer, and then I transfer it to my computer, and then I would examine that image, right? And sometimes we even do a copy of that image. Any question? Okay. So here it tells you a little bit more about UEFI, how it supports larger storage, 2 terabyte and 64-bit device driver. It's able to support GPT, which is a different way that we can section up the drive, like how you divide up section of the drive for a certain operating system or certain storage data. And then the older type of partitioning, we use MBR, which is master boot record. Master boot record only allows you to have 4 drive, right? And you can have specific primary ones. So traditionally, if you don't specify, it's going to revert back to the MBR, but you can specify whether you want to use master boot record or GPT. So similar to having a house, right? So let's say that we have a large house. Master boot record can only allow you to section your house into 4 rooms, 4 sections. And then some section has to be the primary, that would be like your living room. And then the others would be whatever you want to use it for. And with the MBR, so sector 0 is going to be the first sector on the disk. It's going to hold the information for that partition. So it's going to reference that sector to say, oh, which partitions, right, is which. And also the file system, if I'm using Windows 10, that will be NTFS, NT file system. If I'm using an older operating system, let's say Windows XP or prior, that might be FAT. So FAT. And the bootloader code, that's going to allow you to install the operating system. Now, GPT is a little different. It allows you to section your house in many sections, not just 4. So GPT was integrated so that way we can make 128 partitions. So imagine that we can go from a house with 4 rooms and 1 must be a living room to a house with 128 rooms, right? And so this is a way that we can have many different sections on our drives, because our drives got bigger. compared to the olden days where our drives were limited in size, right? So traditionally, and we still use MBR, it's just when you go through the installation process or the partitioning and the format disk, you're able to specify which one that you want.
Are these software or hardware?
It's part of the software level, but it controls the hardware. So this is part of the OS that we can use to control the drive. So when you're installing the operating system, right, you can divide up your drive into many sections, like 128 maximum, or you can have up to 4. Right? So you would have like one primary, like one living room and 3 bedroom, or you can have, but one active at a time. So your active is going to be where the OS is going to be. Okay. So that would be your GPT information. And then here it talks about forensic media, which is a storage that the type of storage that we would use for investigation. So for question 4, it says, what information does MBR contain? The partitions, right? Partitions, think of it like room partition in your house. The division on the drive. File systems. The type of file system that the operating system needs to organize its file, right? So FAT, file allocation table, have a different organizational mechanism in how the files can be retrieved or stored. And then compared to NTFS, which is a later file system for the operating system. Now, NTFS allows you to have encryption and also file permission, so there's more security. That's why we're still using it. But your external hard drive and your flash drive uses file allocation table, but for 64-bit, right? So EXFAT, EXFAT. Now, your file, we know that it's dynamically stored, so file 1 can be in different spaces in the drive. It doesn't necessarily put it all sequential in one, 2 consecutive location. And then it also contains your bootloader code for the install operating system. So that's how it's able to know what kind of operating system is need to be loaded. So the main difference between MBR and GPT, as I mentioned, GPT can allow up to 128 partitions, where MBR, master boot record, can only contain 4 partitions. Like a house with 4 rooms, that's the MBR, or a mansion with 128 rooms, that's GPT. So as you know, when you look at this, right, I might have a small house with 4 rooms. That's traditionally, drive was a lot smaller long ago. And then eventually, we have larger drives. So now if you have a 2 terabyte, right, you can cut that up into 128 partitions. And also, you can also have 128 drives, right? I don't need to cut up each drive. I can add on 128 drives if my system allows it, right? Like, let's say that I have a supercomputer that I'm able to add on a lot of different drives. In an older computer, if I'm using MBR, I can only have 4 hard drives, 1 for each room, right? Or I can have 1 drive and I can cut it up 4 ways. So that's the true difference between the two. So before USB, I think the industry really used optical drive and optical drive kind of went away, like Blu-ray, DVD, and CD. I know that you still see them being sold with movies and things, and you can still buy rewritable CD and DVD, but they're not commonly integrated in the PC anymore. So before you creating an image of a computer, and when the drive is not removed from the system, what do you really need? You need a bootable optical disc. So you need to create a boot disk or a USB that is bootable. And in the Windows OS itself, you can actually go through and create your own bootable USB, right? And that would allow you to have some boot in, like create some boot files and put it there so that way you can boot to it. So that means that when I need to use it, I need to go in and change the boot priority, like what we talked about earlier. So before you make an image, you need to make sure that you have your boot disk, whether it's CD or DVD for an older computer or a USB. Okay? And so when you plug that in, you need to make sure that you change your boot priority to USB or the optical drive. So go to BIOS or UEFI to be able to modify that. Then you will be able to capture the image of the drive. So we want to be able to only create the image for the drive, which contains, you know, the applications and everything that it needs. So the system image. Now, before you use your bootable disk, what should you do? You need to test it and make sure that it works. So I would test it on a similar system. So I would simulate the event by using a similar computer to see and make sure that it works. So you would use the lab environment to make sure that there's no change made.
The lab environment means like a VM.
Yeah, you can have a VM or you can actually have a physical computer. Yeah, attaching the bootable device to the VM might be slightly different than doing it on a regular computer. So if I need to capture an image on a PC, I would try to test it on a PC first to see if that works. And the most important part is that we don't change our evidence, right? We don't make any changes to that computer. So how can you find the software to make your bootable disk? So last time we talked about Paladin. Paladin gives you a lot of different features. You can also use Rufus. And there is also Unit Bootin. So you can use, these are the three mainstream one. I'm sure you can find others. So if I need to create bootable disks for forensic, I can refer to Paladin. If I don't have access to that, I can go and look up Rufus. I've used this before. It's fairly easy. And then you can also use this tool, but there are others that you can find. I think now we mainly use USB, right? But a lot of these software also give you the option to make optical if you need to make optical. But I think even the older computer has USB, so it's probably more of like a universal solution is to use USB, universal serial bus. Any question? So where can I find the answer that I just recorded? You can find that on page 3. It talks about how you can use Paladin. For Linux, there is also a way that you can create your bootable USB. And then Windows-based bootable environment known as WinFE. So you can do Windows forensic environment. And you can go to this link to find more information. You can also use X-Ways or FTK imagers. So there are other tools that you can use. Some of them are proprietary. Some of them are open source. Okay. And then in the next section, it talks about secure boot. So if you want to use bootable forensic operating system, make sure that you disable secure boot. Okay. You can press one of the function key and you would refer to the manufacturer documentation to make sure that you disable the secure boot. Okay, that's important. Okay, let me bring this down, I think, in case you. Okay, so let's talk about drive geometry. And this is for hard drive, right? I know that the majority of the drive that we see in the market is solid state. But you do still see a lot of HDD being used in the computer. And until we fully transition completely to solid state where hard drive is no longer being used, then we don't need to talk about it anymore. But we need to understand hard drive technology to make sure that we understand where the data goes. So on the drive, you have cylinder, which contains platters. And each platter contains tracks. And each track has sectors. And each sector has 512 bytes or 4096 bytes, depending on the type of drive. So most standard you're gonna see is 512. So the smallest unit on the drive is a sector. And as earlier we said that sector 0 has the boot coding information and the partition and all of that. So the boot information is in sector 0. Then sector 1 would contain, you know, your files, your data, your OS data, and so on. And so your sectors are stored onto tracks. And the tracks goes on the platter. And the platter is on the cylinder. It's open. Let me see if I can find it. Okay, so earlier we talked about motherboard, right? No, most of you know this already because I know some of you took my class. Okay, processor goes here. Okay. A lot of the time you would see a heat sink on top of the processor, which is this, right? Normally it goes on top like this. Its job is to absorb all the heat from the processor, right? And this is a traditional board. The new board has other, you know, heat sink and so on. So this is just a fin to draw all the heat. This one, you guys know what this one's for? It's also a heat sink. but it's for what kind of chip? You're studying for computing, you should know this. So this one is a North Bridge. This one is a South Bridge. Each of the chip is in charge of components that's related to it. So the North Bridge is gonna control RAM. Okay? It's the chip that's gonna control how RAM is communicated. The South Bridge is gonna control what's south of the motherboard, which is the components that's attached to the buses here. Okay? That means what? My video adapter, my network interface card, all the extensible devices that goes on the buses. The chip that's in charge here. Okay? Now the drives is gonna be connected via either the connection with, your SCA or depending on the back. So this one uses a ribbon, so it's old, right? And the ribbon, when you're using the ribbon, the red part on the side is your pin 1. But as we were mentioning earlier, we don't open drive like this, right? Once you open the drive, it's done. But this one is bad already, so we open it up. So when we say sector on a platter, right, you see the round, okay? So each sector is like a section onto the actual platter. And the platter, right, goes on, and these are cylinders, okay? Some drives have more than one cylinder. But when it reads, the read and write head doesn't actually touch. Don't think of it like a record player. You know how record player, the needle goes and it touches the record? Yeah, the read and write head moves back and forth, which is the mechanism, but it never touches the pouch. Okay. Now, in the back of the drive, you should see like a board like this. That's just basically for the controller of the drive. And we don't also touch that either, but it has a chip that has the drive information, the sector, and they have low-level programming goes on it. So when you open up a drive and you're referring to the cylinder and the platter, this is what it looks like. So in a forensic environment, so if someone take a drive, open it up, right, and they still retrieve it, ideally because it's vacuum sealed, any kind of form of dust can also ruin the drive. But you can also take it to a clean lab environment where they can actually take the platter out and use the platter. And the equipment for that is very expensive. So we don't normally do that in the regular forensic environment, but if you have a lab like that, you can. So a hard drive that doesn't have things open, it's gonna look like this, right? So it's gonna have a seal and it has a screw, and so to open it up, we simply unscrew it, but once you open that up, you expose that to air and dust, and that can cause damage to the drive, so your data is corrupted. Okay, so it'll look like that. So I'll leave it up. Look at it. Okay. So we talked about the drive and what that looks like. And then for the master boot record, your active partition must be the primary partition. And that is going to be used to boot the operating system. So when you look at your disk management, which I will show you shortly, right, you would see that it will mark active primary, and that's where your operating system sits. That's where it's able to retrieve your Windows operating system, right, files and components. So for the master boot record, the primary partition, when it's marked active, then it is a bootable partition. It contains OS. I don't think I have. Second, let me see if I can show you. So this is my disk manager, right? And you can access this on these computer. They probably limit your privilege, but you can right click your Windows button and go to disk management, or I'm sorry, computer management, which is this, which brings me here, and then you click disk management. So here at RCCD, they probably don't let you see this. But when you look, right, so I have a drive that I purely store data on my laptop, and you can see it shows me my file system, NTFS, and this is the storage size. And then, so that's my disk 0. My disk 1, you see where this is my OS, this is my C drive, and if I put my cursor on it, you can see, right? It has boot, page file, crash dump, basic data partition. So that's my operating system. Okay. And then I have some recovery section on my drive. So in case I need to do recovery. And then for the UEFI or the EFI, that goes here. So on the disk, you could see that it would section, and you notice that there's only 4 rooms in my house, right? I have 1 drive and then another drive that has 3 sections. So a total of 4. And then at the top here, you can see that it would would also list, and you can find that. So in Windows Disk Manager, it would show you. And then if I have unallocated space, like space that's not used on my drive, it also show that there. Or free space is different than unallocated space. So unallocated space is like dirt land in your yard that you haven't used, okay? But free space is like you put a fence around it, but you plan to do something to it, or maybe you put grass on it. You will make use of it. It's just there still, right? So the Windows operating system treated a little bit differently on how that space is being named. So when you deleting files, right, your files, it makes that space become a slack space, which is part of the, sometimes it goes back into the unallocated space. It's kind of like, you used to grow a tree there, and then you cut down the tree, and now it's just dirt. So it becomes part of the dirt land again, right, in your yard. Okay, so we got some tool information. Here's your drive information. You can see page 4, right? Yeah, it shows you platters, and then on cylinder, very similar to what you see. So the actuator and the head, so this is where the hard drive breaks, is the mechanism. So when things can't move and be able to use the read and write head anymore, that's when it breaks. And then sometimes you have the head crash is when it touches the platter. Normally you would hear grinding noise in that case. Okay, so here it gives you the layout of what the track look like, what a sector look like. So there's the sector, right? And then you have a track, and then you have a platter, which is the entire thing, and then the cylinder is how it's stacked. Okay. Next. So what is the purpose of volume boot record, or your VBR? This is used to boot the operating system, and it is located at sector 0 because it has your boot code. In Windows, it still uses boot INI, which is a file for, a loading boot file. But in sector 0, it contains, like, my C drive would have the all the boot files that it needs to be able to pull for the operating system. So that sector 0 would reference that drive where it would have the bootable files that it needs. Now we also have extended boot record, or your EBR. This is basically a space or a record that points to the extended logical partition. So when we cut up rooms or partitions, right, in our drive, we can also have extended logical partition, where that's just like an added space. So think of a house where sometime they would add like a sunroom in their patio section, or maybe a storm room in the East Coast that's very popular. That's like, your front door, and then you have this space where you take off your snowy coats and rain boots and things like that, and you would have a storm door where it's gonna seal out some of the cold and so on. So that's just an extended logical space that your drive would contain, and it uses extended boot record to reference that extended logical section. Now your GUID in GPT, we know that GPT is a way that we can cut up a drive into 128 sections. But GUID is known as globally unique identifier. It uses hexadecimal value, basically for addressing, to identify different aspects of the computer system uniquely. Remember that the computer, it usually use some kind of numerical value to see something. So when you're storing a file, it just references the address where your file is stored. If there's section on the drive, it uses a number to reference that section. So this is a way that it can identify, right, a numerical value that's used to identify different aspects of the system uniquely. Think of it like almost like an address space, but it's just a numerical value that's used. Any question? Okay, so I skipped over this, but I want to briefly summarize this. So when you see SCSI, that's SCSI, this is an older type of drive. We used to use this a lot for backup data and so on. Some company, they still have this. There are 16 devices, so you can have 16 drives interconnected. And on the last one, you have to have a terminator. Okay, this kind of phased out a long while ago, but don't be surprised if you still see them. They are like designed to be used for backup or data storage faster than your normal hard drive. Your IDE and your eIDE, this is exactly this. Anytime that you see a drive that uses a flat ribbon like this, which is this one, that's an IDE or eIDE, right? It has a 40 pin with a missing pin. And then when you install it, you just make sure that that missing pin is lined up with the roll that has missing pin. So the flat ribbon went out a long time ago. And then now we use mostly SATA, which is an L-shaped connector. It looks like a USB cable, but when you look at the connector, it looks like an L. So that's a SATA. We use SATA 3. So these are just interfaces. So when we say interfaces, basically how we're connecting to the drive. The ribbon way, right? And then SCSI, you can interconnect the drives together. And on the last one, you have to have a terminator. You terminate that signal so that way they don't communicate across. And then SATA, as I mentioned before. So as we change the interface, we have gotten faster, right? With serial advanced technology attachment, that's what we're using now. And then we also have the serial attached SCSI, which is used for like more of the backup systems or commercial data storage environment, like data center. You see some of those. And then many of you are familiar with solid state. So solid state, there are a couple of types of solid state, right? Whether you're using the PCI Express one or the NVMe. So you can have different speed in solid state on how they're built. And that's flash technology. So there's no moving parts compared to the hard drive. Now the wear level, because it uses chip, right? The chip are used synchronously, so it wears about the same. And then you can also use trim to wipe, and it does garbage collection. So the firmware is, it scans, and then if it's not in use, it's gonna flush it or delete it. Primary and active partition information is located here. We answered that question earlier. Okay, so when you do forensic, it's gonna look like this. On forensic software, you're gonna see hexadecimal value like this. Okay. And then sometime on the right, you'll be able to see some information like missing operating system like this. And then sometime in our software tool, when we click on a certain section, we'll be able to identify certain things. So when you do analysis, your drive is going to look like this. Okay, so you have to be more comfortable at looking like this. Remember how it talks about hexadecimal value, right? That's what it looks like. So here it says the first 440 bytes that are highlighted is going to be your boot code. Okay. And then the 4 bytes of the disk signature identify to the OS. And then following that, the next one is going to be your partition table. That's how it knows how many partition you have. So some section logically is laid out. It's going to identify, how many rooms on the drive, what kind of OS is on the drive, and which room or which partition. And then if you're using an MBR, it's the final 2 bytes. So make sure we read through this, through the notes. I know that I just summarized them, but you would be more clear when you're looking at the description for this. Okay. Okay. Next few questions. Okay, so for 14, it says, what is the purpose of host protected area HPA and device configuration overlays your DCO? These are hidden areas on the drive created by manufacturer. The HPA is used by the manufacturer to store recovery and diagnostic tool and cannot be changed or accessed by the user. It's programmed at the low level. The DCO is an overlay that allows the manufacturer to use standard parts to build different products. So let's say Western Digital makes the drive, but they actually buy parts from other organization that is standard because it saves money. So the DCO allows them to do that. So when your drive is damaged or malfunction, right? When you send it in to the manufacturer, they would access the HPA and be able to see what's wrong with your drive. So it has diagnostic tool possibly and be able to do recovery.
Where's that on the notes?
I think it's in the later part. Let me see. It's on page 12. Yeah, make sure we read through the GPT and the MBR. It shows you the difference on the disk, like how it looks, what it looks like. So HPA and DCO is at the beginning of 13. So when you're running a forensic software tool like X-Way, it's gonna list it like this, right? And then for FTK, it's able to do that because the software actually access the HPA to determine like how many section of your disk and what's on your disk as far as the partitions and the sectors. And then FTK, it looks slightly different, but it's still able to determine like how many sections. So a forensic software tool access those hidden components. Okay, file system. We talked a little bit about file allocation table. This is an older file system. The older operating system in Windows used it. So FAT12, FAT16, and 32 were used for operating system, the legacy operating system. And then VFAT came about Windows 95. Now, currently, if you're using FAT, you're using EXFAT. That allows you to have volume that is larger than 32 gigabyte. So when you buy flash drive, they are EXFAT because EXFAT is compatible with all operating system like Mac OS, Linux, and Windows. So we can plug it in and be able to run it on a Chromebook or, run it on an Apple system or a Windows PC. And we can have drives that are bigger than 32 gigabyte. Smaller is okay, but we can also have bigger. And so for the VRB and the backups, it's stored in the reverse area. Typically 32 sector on the first allocation table begins. So it gives you the image here. So you know the hex value that you looked at earlier, each one of them have some kind of indication, okay? So at the 0, when you look at the picture, you're gonna find jump instruction on how the system can boot. On the hex 03, that's gonna be for how the system is gonna format the device. And each of those location tells you a little bit more information about the drive. Okay. Okay. And this is for a file allocation table. So if I want to see the file system type, I'm going to go to this. And on the software I'm using, when I put the cursor on it, it's going to indicate some kind of value. That's going to be the area for the file system type. So when we say a cluster, basically that's just a group of sectors combined. And sometimes they are, because they are commingled, right? Sometimes that can be confusing. Okay. So when they say that, what does that mean? Your file can be spread across multiple clusters because your drive is dynamically stored. So that means that file 1 can be here, a little bit can be here, and a little bit can be in the third cluster. It's not always sequential. So whenever that you open a file, it's gonna go and retrieve it at the address from different sectors in that cluster. Cluster is just a group of sectors. Okay. Okay, so what is the functionality of the file system in an operating system? Basically, it's used to track where every file is stored. I should say stored. Sorry, I'm missing that here. Is stored. And how much space is available within the partition boundaries. So if I have a picture, right? It has a reference list or a table or a way to track where that picture is stored. It doesn't necessarily store it in one location. It could be in multiple addresses, right? In different part of the drive, in different sectors, or different area of the drive. So what you see is you see that it's able to find or make my file accessible and retrieve or store my file, right? So every operating system has some form of file manager. It's a way for us to interface with our system storage device to be able to save our file and retrieve it. But using the file system, it is a way to track it through addresses, right? Or numerical value that's assigned for that, the internal storage for that drive.
Is this gonna be a test paper?
It might be, but more importantly that you understand. Because soon you guys are gonna file carve and then you're gonna need to know what you're looking at. Okay. But importantly, we have to understand the functionality of our file system to find file. Right? So make sure we read through the notes, right? I can't emphasize it enough. So here, it talks about file area, right? So when we make a folder, that's a directory. When we make a subfolder, that's a subdirectory. we put a file inside the folder. So it needs to organize it. Yes, it displayed that to you. So if I go to my data drive, I'm able to see all my folders and all my file. And if I open up a folder and open up the file, it's able to pull that up using multiple addresses. So it is a directory to track your file by names based on addresses, starting with the cluster of the beginning of your file to the complete file. Okay. So if you're using file allocation table 32-bit, it's going to look something like this. And then this is a illustration on how, so the offset, the hex 00, that's gonna store the first character of your file name and the status, the status byte. So it's gonna use hex 00 to say, oh, this file name start with, let's say if I have file 1, it starts with an F. And the status byte. Then the next hex, the next offset, it's gonna be 7 byte. It has your complete file name. And then for your file extension, it's gonna take up 3 bytes. Your attributes. Attributes are actually not permissions, okay? It's used for like backup and non-backup kind of environment. So, and then the reserve, and also here's your timestamp. When it was created, and then when it was accessed or modified. So in the file itself, it reserves some sizes in that storage to be able to contain that file information, right? So that way it can retrieve it. And then it also goes into like the last write, the last time you save it. And so it will, so if you look at the specific number, like the 00, right? So when you do forensic software, what does it do? It examines these areas so that way it can give you what kind of file it is on that device. And you see some of that today, right? When was it created? When was it saved? Who created it and so on. So it basically go to these locations on the drive to be able to pull that up for you. Right? Because if we do this manually, that can take a very long time. So we have software to do that now. And then also when you're using characters, right? A lot of the time characters are not permitted into your file name. Like you can have underscore, but you cannot have a colon. So there are limited character because they're not allowed in the encoding for the file system to understand. So that's why you're not permitted to use those characters. Okay. And then when you have special permissions and things, that also goes into if you took assembly, this looks kind of familiar in assembly because it's low level. Right. Okay, long file name, we can have a file name up to 255 characters. And with that, we have to reserve a way. So the first 6 characters converted and it's going to show it as an alias. That's how it's able to put that on the table. And then all the subsequent, then it's gonna start with the number to have an increment for the subsequent. Most people don't use long file name, but there's some that would use long file name, and you can have up to 255 characters in file name. So the system is able to organize that so that way it can retrieve your file as a complete file name and how it's stored. Okay, so for 16, explain how file allocation table or FAT, F-A-T, is updated when the user adds a file. So as the user adds the file to the data area, the system will update the file allocation table. A file may occupy one or more clusters. We talked about that. Additionally, the clusters may not be sequential. So you could have data of a file spread in different physical location on the disk. We typically refer to this as fragmentation. So your file is scattered across the drive. For the short file name for number 17, describe the requirement for short file name. In a short file name, 8 characters are allowed, up to 8. If it is less than 8, then the name will be padded with a hex 20 or X20. When I say hex, it's just, that's what we refer the X as, hex. The 3 characters that are allocated for the file extension, like the .doc, .dat, right, .bat, .bat. If there are less than 3 characters, which is usually a rare case, then the file will be padded with a hex 20. So anything less than the allowed characters, it automatically pad that with the hex 20. When you're using short file names, the spaces in following characters are not permitted. Like these are the characters: quotation mark, plus sign, asterisk, comma, period, slash, and you find this in the note, you don't have to type it out. Colon, semicolon, less than, sign, equal sign, greater than, question mark, the brackets, the forward slash, and the pipe. The directory entry will always be stored with an uppercase. So directory entry are your folder, your container entry. That's gonna be the uppercase. Spaces and characters are not allowed for your short file names. And remember, short file names, 8 characters maximum. So if I have a file name that has 4 characters, it would then be padded with the hex 20. And then my file extension is going to be 3 characters. Like, let's say I have file.doc, right? That's file is 4 character, then it's going to pad it with hex 20. And then the .doc is still a 3 character, so it's fine. Sorry, I'm trying to keep it where you can see both. Any question? Okay, so how does it allocate the space for long file name then? As we talked about earlier, it will format the alias so that the first three character after the file extension dot will become the extension. The first six character will be converted to uppercase and will be used for the alias. The alias will then add a tilde, which is that wiggly sign character with a following number. So it adds the tilde and then a numerical value. It will start with the number 1 and increase incrementally if there are additional files with the same alias name. So it shortened it by using a tilde, and then it adds the number to it if there's similarity in the file name or the same file name. Hmm?
Is it better work?
I think so. You can check. So the example I have here, right? You can have a file, let's say my trip from 2020 from Hawaii.jpg. This is my picture, right? This is considered a long file name. So what will happen is it's going to convert the characters in the front to the uppercase. So it's going to be my trip. It's going to add the tilde. So that is Kai. It's going to shorten. It's going to cut all of this and shorten it into a tilde. And it's going to do a 1 and then you're going to do JPG. Okay. So that's an example of what you see with long file name. So that's what the table stores. So when I open up, I click this picture, let's say on my flash drive. It's then gonna go to the table, find this, and then on the table, it's gonna reference correlated address on the clusters. It's gonna be able to pull up my picture. But it doesn't store your whole entire file name. It actually shortened it to be like this. So it knows that it is a JPEG and it starts with these letters and it is a long file name. So I can have my trip from 2020 Hawaii, the same name, but let's say 2, 3, 4, 5, 6, then it would also sequentially increment this number after that if you have the same name with some variance here, right? I know in Windows, we can't have, if you start with the same name, it overwrites the same file. So some people, they might have picture of their trip and then they just add 1, 2, 3, 4, 5, 6 in the picture number. So with that on the file allocation table, it's going to increment this because the first part of the name is identical. And so that way it knows the difference in the files. Any question? So for forensic purposes, we need to see what the computer see. That's really important. You cannot have the vision of the user. You have to have the vision of the computer. What does the computer see? And that's very important to emphasize, right? We have to look behind the scene to make sure that this is what it knows, this is what it stores, the information that it has. Okay, for the question 19. Sorry. Let me see if I can make it where. Okay, so how do you recover deleted files for evidence? Right? Let's say that the user deleted the file because they know that they might be investigated. One, we need to find the first cluster of the file. That's gonna tell us the size of the file and the size of the cluster in the volume. Two, we need to determine the file size by evaluating the first 4 bytes. So the size of the file is really important, right? And then the size of the cluster on the volume, that's where we start. Then we're gonna narrow down by looking at the last 4 bytes is gonna tell us the file size. Then we need to determine the sector size from the file size. Because if it is a very large size file, like in megabytes, you know that it's gonna spread across many sectors, and that's gonna be in clusters, multiple clusters. So the file size is gonna kind of give us more of like where it should be stored, how many sectors or clusters. Then we can obtain sector information in the boot record, right? Going back to the beginning, remember that it has some information about the sector. Any questions? Okay, so those are the general 3 things that we would do to start carving file. So when files are deleted, right, it tends to go into a thing called slack space. So this space contained data from the previous file, meaning that when it was normally stored, until it's overwritten. So if I delete a file, that space that used to be my file become a slack space. It becomes available to the drive and to the OS until something else goes there. Okay? It's kind of like you built a house on the hill and one day you demolish your home, right? That hill and that space is still there until another house is built there. So that slack space is just a space that's continue to be available until something else goes into that space. Until it is overwritten, that data will remain for you to examine. So that slack space is important. As long as it's had not been overwritten, we can find data. Okay? And this tends to be the issue with malware also, is that when malware is contained, it's just still in the system, but it's just not spreading. However, when it's removed, or let's say that you have a bunch of malware and then you wipe the drive by reinstalling the system, the operating system, well, can it still resurface? Sure. Because if that space is not overwritten by the new operating system and the new files, it can still be there, right? So files are not completely being removed unless it's completely zeroed out or overwritten. So the way that we can get rid of files completely is to use a software to zero everything out multiple times, right? So basically we write it over with the zero value until there's no more trace of the file. But if someone deletes, so let's say that I delete a bunch of picture and I throw away my micro SD, can someone retrieve it? Sure. If my picture, my space is not overwritten by another picture or another file, right? Someone can still retrieve my data. So this is why, you know, we have to physically destroy things if we don't want that to be recovered, or zero everything out. So when in forensics, slack space is a treasure for us because we're able to carve out things. You might not be able to retrieve the entire file sometimes, because they're, you know, remember your files are scattered, right? It might not be able to pull the entire file because some of it is maybe overwritten in other clusters, but you're able to still at least recognize what kind of file it is sometimes and so on. So any question? I think that's all she writes, right? 20 questions? Okay. I'll go ahead and stop the recording.